8.2 today. We're starting on it. We will not get finished with it. 8.2 and 8.3 kind of go together. We are going to talk about rational functions. Now, when I say the word rational, not rational, rational functions. When I say rational, what should come to your mind? Fractions. Okay, so these are fractions, but they're not just any fraction. It is a function that is a fraction, but it has an x in the denominator. That's what makes it a rational function. Okay? So we are going to just take a minute, and we're going to graph the parent function. Y equals 1 over x. All right? So I'm going to draw me a big graph. And we're just going to make us out a T-chart and graph it that way, since we really don't know a lot about it. All right? Anytime you don't know a lot about a function, you want to know what it looks like, then you can always pull out the old T-chart trick and graph it and see what it looks like. Okay? So that's what we're going to do. I am going to kind of be, I'm going to make out, now, I'll tell you what, let's just talk right now about this function's domain. Oh.
0 to positive, from negative infinity to 0 exclusive, and from 0 to positive infinity exclusive.
Okay, so Spencer gave me kind of really what I wanted, which was interval notation for my domain. And the rest of y'all were thinking that, right? Because you were going anything but what? 0. Okay? Why can x not be 0? And so?
You can't divide by 0.
Okay, division by 0 is undefined. Okay? So you can't have a 0 in the denominator because division by 0 is undefined. And so my domain is any number except 0. So that's from negative infinity to 0 exclusive, union 0 exclusive to positive infinity. And that's what that says, any number except 0. All right, so we're going to come back and we're going to look at our graph and we'll talk about the range. But I want to, I'm going to make 2 T-charts because I'll make one for the left-hand side and one for the right-hand side. Let's pick these, I'm going to pick these numbers. -4, -2, and 1. I'm going to pick the same numbers on the right-hand side, but I'm going to put them down here. 1, 2, and 4. Okay, so let's just put them in. All right? Yes, thank you. Yes, let's just put them in and see what I get. What is 1 over -4? Okay. So at -4, it's -1/4. All right? What is 1 over -2? How about -1/2? Are y'all with me? At -2, it's -1/2. What's it doing? Yeah, it looks like it's going down. All right. What about -1? What's 1 over -1? -1, so at -1 it's -1. Is it still going down like you thought it would? Okay. Let's talk about what it's doing out here. Alright? Obviously, he's going like this. Now, is it a line?
No.
No, y'all, it's not a line, okay? It's not a line, it's a curve. Alright, so what's going to happen as I keep going out here? What if you get to -10? Going to get closer and closer to this x-axis, right? So, yeah, I agree with that. It's going to get closer and closer to this x-axis. Is it ever going to reach the x-axis?
No.
In order for that to reach the x-axis, what would y have to be? 0. Okay? What? Okay, and that's what I keep getting all day long, but that's not right. Okay? So I'm gonna try and teach y'all something. Okay, don't write anything, Spencer. I don't have time. Well, just do a little scribble and let it go. Thank you. That's good. Okay. No, never mind. I lied. No.
I don't trust it. Okay, DNA.
Okay. So here's, I'm going to repeat my question again, okay? Because we've already had somebody that sacrificed themselves on that question, right? So you know what I'm not looking for, if you were listening. Oh, stop. So here's what I was trying to ask you, okay? I was saying, when can y be 0? How come this thing will never get to 0? Why can this never be 0? Because what? Y'all listen to me. I want to know when this right here is going to be 0. Why? Thank you. Y'all listen to me. Does this denominator have anything to do with this thing being 0? No. That's what I keep trying to get y'all to see. Last period, that's why we got in a fight. Okay? Because they kept trying to justify their answer, which was because x can't be 0. People, I don't care. It has nothing to do with x. What would have to happen in order for this fraction to be equal to 0? Yeah, the numerator would have to be. Do I care what the denominator is? Y'all, what's 0 over 1? What's 0 over 1,000? Y'all, it's 0 over anything is 0. It has nothing to do with this bottom number. It has everything to do with that top number, the numerator. It can't be equal to 0 because the top's a 1. Can you change it?
Right now,
like, can I change this 1 into a 0 right now? Is there any way to do it in this problem? Yeah, it doesn't have a variable up there. It's not going to vary. Okay, that's what a variable is called, a variable, because it varies. All right? So, he can never be 0. Why? Why can this never be 0? Because the numerator is a 1, and you can't make it a 0. That's why. Okay? So, he's going to get closer and closer and closer to 0. When I say 0, am I talking about the x? No, I'm not. I'm talking about this y, the whole thing. But he's never going to get there. All right, now let's go graph this one. At 1, what's 1 over 1? What's 1 over 2? What's 1 over 4? All right, so at 1 it's 1. At 2 it's 1/2. And at 4 it's 1/4. What's he doing out here, guys? He's doing the same thing. He is approaching, big word, okay, a good word, approaching. What does approaching mean? Getting closer and closer to, okay? Now listen to me. A lot of teachers will say he gets closer and closer and closer. Because does anybody know what this line right here is called? Yeah, it is that. But what is it called with respect to this problem? It's an asymptote. Okay? Asymptote. It's an asymptote. An asymptote is a line your graph approaches. A line your graph approaches. Now listen to me. Is it a graph your line approaches? No, it's not, y'all. Kids say that all the time because they flip those two words around. You can't flip those. A line doesn't approach something, okay? The graph approaches the line. It gets closer and closer and closer and closer to it. But it doesn't ever reach it out here. But don't say it can't ever cross it, because later on, we're going to graph things, and they're going to have like 2 vertical asymptotes. Maybe they'll have one side over here and one side over here. and then this middle part, he might, doesn't have to, but he might look like that. Did he just cross over that asymptote? Yes, he did. Okay, and then that wigs kids out. They're like, oh, you can't do that. It's an asymptote, you can't touch it. No, no. What makes it an asymptote is because my graph approaches it here and here. Okay? It's not that I can't ever touch it. All right? It's just what makes it an asymptote is if your graph approaches it, then that line is an asymptote. All right. So there he is, there and there. There's my asymptote. Now, let's see what he's doing right here, because we don't have anything, and I don't think he does that. I don't think he goes from here to here, because then he would have to cross what? Where x is what? 0. And we know that x can't be 0, because that would be division by 0. It's undefined. We took it out of our domain. All right? So let's put some numbers in there. Most of the kids like to start with the positives. They don't want to play with the negatives. All right? So I'm going to start over here close to 0, and I'm going to pick me 3 points between 0 and 1. Am I going to pick 0? No, we know x can't be 0, people. There's not any sense in picking it. Okay? So I'm going to pick a fourth. I'm going to pick a half. And I'm going to pick 3/4. Okay? That gets me pretty close to 1, right? Everybody okay with that? All right. Now, well, a compound fraction is not legal, is it? Okay. So let's talk about what happens. What happens if you put 1 over a number? What do you get? That number's what? Reciprocal. That number's reciprocal, right? Look. What's 1 over -4? -1/4. What's 1 over -2? -1. It's always his reciprocal. All right? So when you put 1 over anything, it gives you his reciprocal. So what's 1 over a fourth? 4. So at a fourth, oh my word, that thing jumps way up here to 4. Okay? What about a half? What's 1 over a half?
2.
So at a half, he's all the way up here at 2. What about 3/4? That's 4/3. Let's write that as a mixed number because it's easier for me to graph. What is that? 1 1/3. So at 3/4, it's 1 1/3. Now, do you see what he's doing? What's he doing up here? Yeah, he's approaching that y-axis. All right? He's getting closer and closer to when x is 0, okay, which is really a, down here on the x-axis, it'd be a small number, but up here it turns into a really big number. All right, and he's going to do the same thing over here, guys. He's going to approach right there. That means that my y-axis is also an asymptote. Very good. And we draw an asymptote with a dotted line because it's not really part of our graph. It just helps someone understand what's going on. Okay? Now, what is the equation for this asymptote right here, this vertical asymptote? Very good. X equals 0. So could I say this? Could I say it has an asymptote at 0? No, because what is an asymptote a number? What is it? It's a line. So you can't just write a number. You can't say, what are its asymptotes? 0. That's the asymptote. You can't say that. You have to tell me what it's a line. So x is equal to 0. What's the equation for this asymptote? Very good. Y equals what? Y equals x is right here. That's a slanted line. 0. How about 0? Y is equal to 0. So those are my asymptotes. Now, what's his range? What's the range of this function? From what? Negative infinity to 0. Okay? 0 is that asymptote, guys. He's not going across there. All right? He faked me out. To 0. And then union what? 0 to positive infinity. Okay. Now, everybody okay with this so far? This is the parent function of a rational function. Now, what if I did this? What if I said, what would this one look like? Y is equal to 1 over x minus 3.
It would move to the right 3.
People, that minus 3, he's with an x. So what is he? An x. X's go with x's. and y's go with y's. And yes, he's weird because x's are always weird. So if I say minus 3, all it did was shift this whole thing where? 3 units to the right. Is his horizontal horizontal asymptote changed? No. Is his vertical asymptote changed? What is it now?
To positive 3.
X equals 3. You see it? It went to the right 3. Okay, what's he going to look like? 1, 2, 3. There's my little vertical asymptote. All right? What if I said plus 2? What did that change? Yeah. Now he went up 2. So what's my new horizontal asymptote? Y is equal to 2. Not 2, but y is equal to 2. And then you still have your little curve over here. Okay? And over here. All right? Everybody okay? Huh? X is still equal to 3? Yep, x equals 3 is my x equals 3 is my vertical asymptote. Y is equal to 2 is my horizontal asymptote. Now look, was that hard? That's not hard. Should you know how to do that? Okay, so explain this to me. How could you, on a test, miss a graphing problem when you have a calculator?
Okay, I'm sorry.
Okay, but did it happen yesterday and the day before yesterday? No. Okay, come on, guys. Like, I'll let you use a calculator, and do you know how many kids miss graphing problems?
Yes.
Yeah. It said, what's the domain? And then it said, what's the range? And then it said, graph it.
Oh, I remember it now.
No.
Was there a graph written? Did we have to run the graph?
Yeah, I drew the graph for you.
I remember that one. Oh, yeah, I remember.
It wasn't that they didn't do them. Y'all just
It's just that they
crazy.
didn't do it right.
Yeah.
Watch out for Q3 with that.
Yeah. Yeah. And somebody graphed a cube root, and guess what they made it look like?
Cubic.
No, a square root. I'm like, what? How could you can't even mistake in those two. Like, you just put it, like, are you just so smart you're not even going to look at it on a calculator and say, I hope I'm right? You're just going to be like, no, I know I'm right. I'm that smart. No, you're not, people. All right? Okay. So, here we go. I want you to take out, or don't take it out, just turn to a clean sheet of paper. Nope.
I know.
Do we need an entirely new sheet of paper? Can I just, write a split with it?
All right. Now, let me tell you something, okay? What did I just tell you to do? Okay, I said turn to a new sheet of paper.
Like new
People,
sheet or like on the back?
whole new
I'm trying to be eco-friendly right now.
y'all listen to me. I don't care if you write on a gum wrapper. It's not my note, and I don't give a hoot about it. I'm fixing to tell you all the directions on how to find all 9 or 11 things that you have to find on every graph. And not only that, I'm going to let it be your cheat sheet, and I'm going to let you use it on the test. Write it on a gum wrapper and then throw it away when you get finished with it. I don't really care, people. I'm trying to do what's best for you, and I'm saying get a new sheet of paper out. But you don't have to if you don't want to. I'm not grading you on it, and it's not my note. Jeez. All right, number 1. See, I knew exactly what you were going to do because last period, after we got finished doing it, they're like, well, are we going to have to use that a lot? And I go, only every time you have to grab something. They're like, well, why didn't you tell us to put it on a clean sheet of paper? And like the other half of the class went, that was the first thing she said was get out a clean sheet of paper and write this on it. So, listening skills, y'all's are horrible. It's this whole entire class. It's not like just, I'm talking about 10th graders. I'm not talking about just like this little 5th grade class. I'm talking about 10th graders. I don't know what y'all skipped something in elementary school. The listening class.
I'm from out of state for 3 years.
Well, you missed it too. All right, so here we go. Number 1, the first thing I'm going to ask you to find is the domain. Now, why is this a little cheat sheet? People, I'm fixing to tell you how to find everything that I want you to find, okay? So the first thing is the domain. Let's think about this problem back here. We found its domain before we even graphed that thing. What did you do? No, we didn't look at the graph.
X was in the denominator.
Okay, so you looked at his restrictions, right? And what did I tell you a rational function had, always? An x in the denominator. So what did you find of the denominator? You found the what? The zeros of the denominator. And then what did you do with them to make the domain? You took them out. Okay? So, guess what you're going to do? Guess what you're going to do on the domain? You're going to exclude the zeros of the what? Denominator. Now, some of you are going to get one more chance to learn how to solve and find the zeros of a quadratic. Because you still don't know.
Quadratic.
Yeah. All right. Let's talk about my range. How did we do the range on that last problem? Yeah. Look at the graph, people. This is the one I miss all the time because I forget to go back and do it. All right? Look at the graph. It'll tell you what the range is. As you do a few of them, you'll learn that there's something else down in our list that has to do with the range, but I'm going to let you figure that out by yourself. Or not. All right. The next thing you're going to find are the vertical asymptotes. The vertical asymptotes. Now, first of all, if it's a vertical asymptote, is it just a number? No. What does it have to be? So what? If it's vertical, what does it have to be?
X equals 0.
X equals. And it's X equals what? X equals what? Here's what X equals. Look at that vertical asymptote. How did we get that?
The number that's with the X in the denominator.
That's exactly right. So what is it going to be? X equals the what? Zeros of the denominator. Very good. Zeros of the denominator. Y'all are playing nicely. I like it. X equals 4. X equals 12. What? You just write them. I just use my pencil and just write them down.
Miss Davis, you're going to kill somebody with me in class because somebody's just going to say something on
No. I have. Oh, stop it. Go away. I got it. Oh, Spencer. There he is. I think you thought you messed me up.
At the same time, my finger was, so I was trying to figure out which one to obey.
Yep. All right. So, now, here's the next one that y'all listen. This one's going to be the bad one. Horizontal asymptote. Okay? Horizontal asymptote. Obviously, it's going to be y is equal to something. Does everybody agree with that? Okay. Now, we're going to, here's what I want you to do. Every time I say horizontal, now listen to me. I've told you things like this before, right? When I say domain, what did I tell you to think? Restrictions, okay? You see how I'm trying to steer your brain in the right direction. So when I say horizontal asymptote, I want you to think degrees. Now, am I talking about how hot it is in here? No. Am I talking about your master's or your bachelor's? No, I'm not. I'm talking about the degree of a polynomial. How do you find the degree of a polynomial? The highest exponent. If you don't know that, you should, because I've already taught it to you. You might want to write it in parentheses or something, okay? It's the highest exponent. Now, before we talk about them, I'm going to go over here, and I'm going to make a little, what do y'all call it, a legend or a key or whatever you want to call it. I'm going to use some abbreviations. I want you to know what they stand for, okay? Because I don't want to write a bunch of mess out. I want my cheat sheet to be really fast and quick and easy to read, all right? So the first little abbreviations I'm going to use is like DD. And DD is the degree of the denominator. I'm just going to go up there. All right, let me see if I can have it, Spencer. Okay, the degree of the denominator. All right, the next one I'm going to write is DN. Guess what that is? The degree of the numerator. I mean, it's not like rocket science or something, okay? All right, LCD. LCD is the leading coefficient of the denominator. Now, what's the leading coefficient going to be? Yeah, it's the coefficient of the highest exponent, okay? It's the coefficient of the highest exponent. And the LCN is going to be the leading coefficient of the numerator. All right, so there's my little key or my little legend. I'm going to use these symbols, and we're going to talk about the horizontal asymptote. All right, so I'm thinking about degrees, right? So you're going to know the degree on top and know the degree on the bottom. So you're going to have two numbers. Now, those two numbers can be one of three things. They can either be, the top can be bigger than the bottom. The top could be, help me out, smaller than the bottom, or the top could be equal to the bottom. All right, so those are my three cases that I could have. All right, so the first one, let's say that the degree of the numerator is less than the degree of the denominator. Okay, the degree of the numerator is less than the degree of the denominator. That's just normal, and my asymptote is going to be y equals 0. All right? The top is smaller than the bottom. Y equals 0, normal. Let's say that the degree of the numerator is equal to the degree of the denominator. They're the same, and so they both get to be represented. Okay? So that's going to be y is equal to the leading coefficient of the numerator, gets represented on top, and over what? The leading coefficient of the denominator, because he gets represented on the bottom. Yeah. Yeah. It'll just be a fraction, you'll need to reduce it. Okay? Over the LCD. Alright? The other thing that could be is the degree on top could be bigger than the degree on bottom. That's bad. There is none. Okay? There is none. There's not a horizontal asymptote. Okay, so now what I want to do is I kind of want to tell you a story and get you some pictures in your head, and you can remember that really easy with a story. Okay? So, here's my story. My children, oh, I love them, all right? But they can be wild and crazy sometimes. So when they were little, when they would go see the cousins called them the thundering herd, okay? Because they were a little rambunctious and they were just loud, all right? There's 3 of them, and they're just loud, all right? So the thundering herd, they had a go-kart. On the bottom of the go-kart was 3 horses racing across, and it said the thundering herd. Okay? So, let's say that I wanted a vase to put some flowers in my house. But remember, I have the thundering herd, right? Okay. So, I'm going to get this vase, really expensive vase. Some people might call it a vase. A vase. All right, but I'm gonna call it a vase because I'm from Arkansas. All right, so let's see. If this vase is smaller on the top than it is on the bottom, in other words, it looks like this. Is that going to be a good vase for my house? Yeah. My kids will run by there and it'll be fine. They're not going to turn it over. It's just normal. That's normally what a vase looks like. So that's the parent function, y equals 0. Okay? Now, what if my vase was like this? The same on the top is the same on the bottom. That's not bad, right? That's equal representation. Okay? The top says, hey, I'm just as big as you are. All right? So I get represented, and the bottom says, hey, I'm just like you. You got to represent me. Okay? So that's y is equal to the leading coefficient of the top over the leading coefficient of the bottom. All right? Then you got this guy down here. Whoa. He's bigger on the top than he is on the bottom. Now, I'm going to tell you what. My kids will just look at that and tip it over. Okay? This is very, very bad. Bad, bad, bad. All right? He doesn't even have a horizontal asymptote. Okay? So, normal, like a triangle. Equal representation, like a cylinder, a rectangle. Bad is that top-heavy thing. Not going to work well. Doesn't have one. All right. So let's write the rest of our stuff down. Okay? The next one is going to be a slant asymptote. We're not going to have time to fill them in, but we'll write them down. A slant asymptote. Okay? I'm going to need about 3 lines to fill that one in. 2 or 3. It's not as long as this one. It's just going to take us a little bit of writing. Okay? The next one after that one is called a point of, that's point, not P plus. Okay? That's PT. Point of discontinuity. The point of discontinuity. I can just take the rest of the line and I'll be okay on that one. Okay? The next one is an x-intercept. These are all the things that you're going to have to find when you graph something. Okay? Now you know why I'm letting you use the cheat sheet? That's a lot of them, isn't it? Okay? Here's the next one. I just need that one line. It's a y-intercept.
How much did you need under the point of discontinuity?
Just that one line. The next one's a y-intercept. And number 9 is a t-chart. Okay? Alright, so we went in a little more in depth in here because we had the time to do it. And we did in the other class. Alright, everybody okay with that? So we'll finish filling this out tomorrow. We'll graph some. First we'll graph some, and they'll only be the top part. They will not have a slant asymptote or a point of discontinuity. Okay? And then we'll graph one with a slant asymptote. And then we'll graph one with a point of discontinuity. Okay? Yeah, something like that. But it doesn't have to necessarily be right to the center to be a